Today we will continue the uh, lectures on the physical design of IoT. So today I hope to finish this section. So we will look at some of the remaining protocols that that are in the application layer. That are related to application layer. When we talk about the IoT protocols. So especially we talked about the MQTT and protocol, and we talked about its function and different scenarios where it is used. And also we talked about the quality of service, how we can ensure the quality of service by specifying the level of quality of service as either 0, 1, or 2. And then we talked about how we can implement MQTT on ESP32 using MicroPython, and how we can define the topics, and how we can subscribe to a topic, and so on. So I think we got some fair information about MQTT. And so we spent a considerable time on MQTT. So mainly it is because MQTT is widely used for IoT networks and applications. And therefore, we need to study about this protocol in this IoT module. So today we'll be focusing on other protocols which are important to IoT, such as CoAP, Constraint Application Protocol, HTTP Protocol, Hypertext Transfer Protocol, Websocket Protocol, and so on. So out of CoAP, HTTP, Websocket, CoAP is more suitable for IoT networks, where the energy of the devices that are connected to the IoT network is low, and the resources at their end is low. So we will first actually look into the HTTP protocol. The reason is that HTTP protocol forms the base for the CoAP protocol. So therefore, we will first start by getting the basic understanding about how HTTP is functioning in general, and then what are the features of that, and how it is used in websites, and how it is used to access websites, and so on. So hypertext transfer protocol, I think maybe if you have followed a networking course, you must have learned about it. So it is hypertext transfer protocol, and it is usually used widely for accessing web services like Google, email, online shopping, social media, and other types of web-based applications. So basically, in here, the HTTP protocol is used to define the set of standards about how a web server and a client should communicate to exchange data and establish the connection to a website. So this HTTP protocol is a protocol that works over TCP. So that means transmission control protocol. So therefore, it is a connection-oriented protocol. So once we are using HTTP, it is a very reliable connection that is created, because TCP creates a connection-oriented communication, and therefore we can have a reliable link with the server, and we can obtain the information very reliably when we are using HTTP. And so basically we have the web server and client based communication, and we basically send a request to the server, and the server is providing us a response. So we have a request response model used in the HTTP protocol. So another important thing that we can see with the HTTP is that we have methods that we can use to obtain data from a certain website, from a certain URL. So we have mainly 4 methods that we can use, which are get method, post method, put method, delete method. So, so once we talk about the get method will request data from a server, right? So basically, once we are using HTTP protocol, we have a client and we have a server, and we can send a request. We can send a request from the client to the server, and based on the request made, the server will send us a response. So so now we are talking about the different request methods that we can use. So the request method can be of 4 types. So it can be get method, right? Or it can be post method, it can be put method, or it can be delete. So out of these, so get method is used to obtain some information from the website, obtain some information from the web server. So we use the get command for that. And then once we use the post command, that means that it is used to create data on the web server. So it will generate data in the web server and present us some data. The post command will present us some data. So once we do a post request, it will generate some data in the web server and it will show that data to us. And next we have the put method, which is used to modify the available data in the web server. So if we have some data already in the website, we can use the put method to modify some information already available in the web server. So put method is used to modify the already available data. Post method is used to create new data. So create new data. And delete method is used to remove some existing data in the server. So basically, those are the common request methods that an HTTP protocol uses. So actually, we can. Okay, now we will actually consider this scenario where we use the HTTP post method to post new information into a website that we have created. So if we are considering an IoT scenario where we are collecting temperature, humidity, pressure information, we can first we need to establish the connection with our web server. So we have if we have ESP32 module, we have Wi-Fi module installed there, so we can establish the Wi-Fi connection with the router or access point, and the router access point can establish the connection with the internet. So the internet will have the necessary it will provide us the website using the HTTP request that we make to the into the website. So into the URL that we make. So first we need to do HTTP GET request. So once we give a GET request to the specific URL that we want, that means, for example, in here, the website is example-domain.com. So once we do a HTTP GET request, we can obtain information, or we can obtain the website, obtain this website, right? And then we can access this website. And then we can use the HTTP post method to post new information into this website. So we can create new data in this web server, and we can store that data in that server. And then after that, we can store those data in a database using some language that we prefer, PHP script. So then we can use a database managing a tool, and we can manage the data, and we can also visualize the data we have collected, and we can get visualized plots and graphs from the data that we have. So this is how we can use HTTP protocol to update data to a website and monitor them continuously using our own device. So we can monitor the situation at the end device from a remote location using this method. So we can use HTTP in this scenario. So we will talk about how the advantages and disadvantages of HTTP as well, right? So then I will now show you, what are the, how we can access, how we can watch the HTTP protocol and its information when we are accessing some website, right? So we can actually inspect the protocols used in a certain website by going to a certain website like Amazon, and then right clicking, and we can go to inspect. And then after we click inspect, we get a window like this, and then we can see all the the links that we have accessed so far. So once we go to these links, we can see the information regarding that. So once I go to first link, I can see that it is a HTTPS request, and I have used the HTTPS protocol to access this URL, right? And then I will go ahead. Once I go in here, I can see that the request method is post, right? So I have requested a post method, and then some data has been posted in this website. So once I actually try to search something in this website, like something that comes first, like I can go to any website. So once I try to search something, then most of the time what is shown is a get method, right? So the request method is shown as get method because I have requested some information from the server. So it is creating a lot of URL requests that that are of the form get. So we can search likewise, and we can see what are the type of request methods that have been used, right? So we saw in that Amazon website, I showed you that they have used HTTPS protocol. So we are going to talk about that now. So basically now websites I mean, especially websites which are doing selling, I mean, selling items and doing bank transfers, they are using HTTPS protocol. So it is the secure version of the HTTP protocol, right? So the HTTP protocol with more secure features is known as the HTTPS protocol. So now actually Google is only allowing HTTPS protocol assisted websites, and otherwise other websites are not that much preferred by Google. So anyway, once we are actually using HTTP only, and once we are using that protocol, the data is sent in human readable text format. So that means the anybody who's using the website or anybody who's using the internet can decipher the information that is transferred from a certain client to the web server. So there could be some intermediate routers and intermediate servers that through which this information, through which this data is going from the client to the server, right? So let's assume that the destination server is in here. So there could be some intermediate servers through which this data is getting transferred. So if there's a server here and if there's a person using this server, that person can access this data that the client is transmitting by reading the data that has been transmitted by the client. So the data packet or the data included in the data packet is in HTML, XML, JSON format. So these formats are human readable text formats, so that the person who's reading this data can decipher the information inside that data. So that person can either erase or modify the already available data. So therefore, it is a threat to the uh, consumers of the network. So therefore, it is essential for us to use secure methods of transferring data across the internet. So therefore, we are using the HTTPS protocol to send our data and request web services and access websites. So I have seen, I have made I mean, check in the Google Trends. So in the Google Trends, once I check the popularity between HTTP and HTTPS protocols, then the popularity of the secure protocol is higher than the HTTP method. So it shows that people prefer the more secure method over the non-secure method. So we have in HTTPS, we have basically two encryption methods that we can use. So one method is called SSL and the other method is called TLS. So SSL is the old version, I would say, and TLS is the most latest encryption method that is used for secure transfer of information using HTTP. So uh, so in these methods, they are using certain specific method of encryption or authentication using usernames, passwords, and digital certificates. That means like they are using either encryption or they are using an authentication method for the data transfer using some predefined digital certificates, usernames, passwords. So before transferring information, they are first sending some control messages to check whether the receiver and sender are authentic devices, and then after confirming that, they are sending information along the specified route. And then, so once we talk about the TLS protocol, so it is using an encryption method to encrypt the data that is sent by the client. For example, if the client is sending information, right? The data that he's sending will be transferred into an unreadable format. Like if the data is sent in a readable format, the encryption that is applied on top of the HTTP will be converting this human readable format into some kind of unreadable format where the intermediate person cannot read this information. So therefore, there's some kind of a encryption method is used to make it unreadable, and then that information is sent over multiple devices or servers across the internet, and it is reached or received by the destination server. Once it is received by the server will use a specific private key that it has and decrypt this message into a human readable format. So that private key is only available with the server, and the client will use a public key to encrypt the message. So if there's any kind of an intermediate person who's trying to hack and obtain this data, that intermediate person does not have the private key to decrypt the data. This person does not, intermediate person does not have the private key, and therefore he or she cannot obtain the data. Even if they try to get the data, they cannot decode it into a useful information format. So therefore, TLS is using this encryption decryption method to secure the data. And then secure sockets layer protocol, that is using an authentication method to secure the data that is transferred. So that means that first, before connecting or before sending data from the client to the server, or from the server to the client, the client is requesting information about the authenticity of the server, and requesting the server to send the SSL certificate that it has. So the server will send the SSL certificate over to the client, and the client, after checking that SSL certificate, will ensure that this is a authentic server, and therefore it will send the data in the pre-established format. So anyway, so beforehand, some authentication is done to authenticate the web server, and make sure that it is a secure web server. And then so that is how the HTTPS method is used. So it is using multiple, security methods to ensure the security of the HTTPS protocol. So actually, I think we already saw that most of the websites in the Amazon, for example, all the URLs were of HTTPS format. And next, actually, HTTP protocol. Now, is it suitable for IoT? Now, that is the question that is specific to this module. So, should we use HTTP in IoT applications? So, HTTP is widely used and a familiar protocol for many computer networks, and it is easy to integrate it with existing web technologies, right? So if we use HTTP, it would be very easy to use this protocol on websites and access the data. However, a disadvantage with the HTTP is that it is having a high overhead, and it might not be optimal for low power devices. So since like HTTP has multiple, like uh, uh, operations to uh, run, and then it has to check for security, for example, and then do some complex procedures before transferring the information. It might not be suitable for low power applications, and therefore also since it is taking some time to establish the connection with the client, uh, it is not suitable for extremely low latency communications, and also high throughput communications. So once we need low latency and high throughput, HTTP method might not be the optimal one, because HTTP takes some time to establish the communication with the client. Therefore, it takes some time to do the handshake procedure and send the control messages and establish the communication. So, therefore, it might not be the optimal scheme for the IoT protocols, IoT applications. And therefore, so the research people, the scientists have proposed a protocol called Constraint Application Protocol, which is known as CoAP for IoT. It had been developed by Internet Engineering Task Force, and it has been designed for direct M2M applications. That means like machine-to-machine applications, and it is designed for uh, accessing, uh, I mean, accessing uh, websites and also other URLs, and then it is specially designed for constraint situations, and that is why it is useful for the IoT applications, right? So actually, once we are talking about CoAP, it is having lesser layers when compared to HTTP. So and that is why it is more suitable for IoT applications due to its simplicity. And therefore, CoAP is good for IoT applications. It is using request response model, and also it is using the UDP method, which is a connectionless protocol, and therefore this is less reliable than the HTTP. However, it uses less resources than HTTP, and therefore suitable for the IoT. And the next thing is that it does not have the client observability. That means it does not know which clients are there in the network. So it knows that there are some clients in the neighborhood, but it does not keep a count of the clients and keep on monitoring the clients. So when we talk about the MQTT protocol, MQTT was able to have a list of all the devices that has subscribed to a certain topic, and some other devices which are publishing to a certain topic. So MQTT was able to monitor the devices that it has connected to. I mean, the MQTT broker was able to monitor the connected devices, but CoAP is not like monitoring the devices to which it is connected. However, it is just communicating with its neighbors as the energy is very constrained. And then um, so once we talk about the CoAP protocol, uh, it is using a request response model. So it also uses this get, post, put, delete commands. So in order to obtain some kind of information, it is using the get request, and it is mentioning the whatever the IP address of the device and the port of the device, and the uh, the serve the website link that it needs to address and the access, and it is then sending that request to the device to which it is trying to connect, and the device will respond with the status of the requested information, and it will send the temperature data in the payload. And likewise, the client and server will communicate using CoAP. And the CoAP communication can basically happen in using 4 types of communication messages. So the 4 types of messages are basically confirmable message, or we call as CON. Then non-confirmable message, which we call as NON. And then we have REST, reset. Reset means we totally reset the communication between the client and the server. So we restart the communication link, or else we have 4th type, which we call as ACK message type, right? So I think I will write it in here because yeah, it is there. So we have these 4 types of messages for CoAP. And I mean, once we are doing communication with using CoAP, we need to define which type of message we are using. That is why these message types are used. So based on the definition that we make in the code, they are responding accordingly to our request method, right? So that means that if we, I mean, apart from having the get, put, post, delete commands, we can also mention that what type of a message we are sending. That means if we mention if it is a con message, then the response or the server will respond in a certain manner. If we are sending non-message, then the server will respond in a certain manner. If we send a reset message, then the client and the server will reset the link, and they will restart the communication link. So the procedure for restarting will be initiated after a certain time period. And then ACK message, that means acknowledgement message. That means we require an acknowledgement. So actually we will see how in example how we can define these message types in the code. So this is one of the codes that has implemented the CoAP protocol. So in this code, if we want to, I mean, this part basically explains about how we can implement the CoAP protocol and implement the request, right? So if we, so I think I need to mention about how the N and CON works. But anyway, I will show you that these words are mentioned in this code to ensure that this is a con message, and NON is mentioned to show that this is a non message. Likewise, we can mention that this is a con message type or a non message type. Also, we can mention that we need a ACK or acknowledgement by mentioning ACK in here. Once we have all these parameters mentioned in the code, we can get the response from the server accordingly. So we will now we will discuss about this non-message and con message. So non-message is a type of message where we send, for example, when we don't want any acknowledgement from the server, right? So let's assume that we are sending some message to the server, but we don't need any acknowledgement from the server. So in that case, we will send a message of the type none. So we send with a certain ID and the server will receive it. So if the server does not receive it, then even the client does not know whether it has been received or not. So that is the disadvantage of this method. So the client will not receive any acknowledgement in this case. There's no acknowledgement in this case, right? So basically in this case, what happens is that the client is saying, I don't need any confirmation. When we consider the con message, so in contrast to non-message, con message is about the acknowledgement. So once we send a con message, it means that we require an acknowledgement message. So we need to, so in that case, once we send that con message, it means that please confirm confirm that you got my message. So the server will send a certain acknowledgement message back to the client device. And then we have certain different scenarios that can happen with the con messages, right? So I mean, even when we are using the con message, if we don't get the acknowledgement, right? If we don't get the acknowledgement back, or if we don't get the necessary information back, then the server will keep on sending us information. I mean, server will first send us information of a certain acknowledgement message, and then it will send the message with the requested data, right? So what I mean is that there are two scenarios that can happen with the con message type. So once we request a certain resource from a server, using the con message type, the server can quickly give information. For example, if this client is requesting pressure information, then the server can give back that information as soon as the client requested, or as at the moment that the client requested it, in the next time cycle, like this. So it can server can provide it as soon as possible, right, with the same token, with the same ID, and so on. However, if the server is not able to provide that information on time, what the server is doing is that it will send an acknowledgement message first, right? And this acknowledgement message will not have the necessary information that this client is requesting. It does not have the pressure information here. It only has an empty message saying that I have received your GET request. That's all. I have received your GET request. So the client now knows, okay, that person knows that I have requested this information, right? That thing that now the client knows. So that therefore the client will wait, and then server, once it receives the pressure information from its sensors, for example, or from other node, then it will send the data to the client device with the same token ID of the request, and then it will send the data to the client device, right? So once the client device receives that data, the client device will also send an acknowledgement back to the server saying that that client has received the data. So the con message is a very reliable way of communicating, and it is using acknowledgement messages to uh, inform the other, client or the server that it has received some data from the other device. So these two scenarios are available. So basically under con message type. Then we have the CoAP protocol, where we have, two types where we can use the CoAP protocol. So we can either use the CoAP protocol for one-to-one communication, or many-to-one, or one-to-many communications. So we can use CoAP for one-to-one communications, right, in the presence of just the client and the server. But in the cases where the number of clients are increasing in the network who are requesting certain resources from the same server, then there are several number of clients, the many clients receiving requesting resources or websites, access to the websites from a single server. So therefore, in that case, many to one communication is happening. And that case, the server will respond to each of the clients individually with a separate message, right? And then the other way also can happen, where one to many communications can happen. So one server can communicate with multiple clients at the same time. So we can actually do like a comparison between the CoAP and HTTP protocols. So because the CoAP protocol is also used to access websites, we can compare with HTTP, which is a similar protocol which is used to access websites. So the basic difference with respect to the transport protocols is that CoAP is working over UDP protocol, where the connection connectionless protocol is used for CoAP. So that means like this is not that much reliable. And when we talk about the HTTP protocol, it is using a TCP. It is running over TCP, and therefore it is using a connection oriented protocol, and therefore reliable communication links are created between the client and the server. And therefore, this is more reliable in terms of reliability of the communication link. So, however, once we are doing the message encoding, CoAP is using binary encoding of the messages, which conserves the resources. However, like HTTP is using text-based encoding, and therefore it uses higher payload and resources to encode the data it is sending, and therefore it is consuming more resources, and therefore not that suitable for IoT applications, right? So this is CoAP is using binary encoding, and therefore it is using less resources, and it is more simple. Therefore, it is more suitable for IoT applications. And therefore, then we also have request methods both CoAP and HTTP protocols. In CoAP, we have basically four commands: get, post, put, delete. However, in HTTP, we have large number of request methods, more than these four basic methods. So we have multiple functions that can be run using HTTP protocol, which makes it more complex to be used for IoT scenarios. So IoT scenarios might only need these four commands, and it will only be, it would be sufficient for IoT networks. Then once we talk about the application, the CoAP is used for constrained environments, or we call that energy constraint or resource constraint environments, and therefore it is more useful for IoT applications. And HTTP is used for general purpose applications. For any type of web accessing, it can be used. So once you have good energy in your devices, that means battery and bandwidth, bandwidth, once you have a higher bandwidth, then you can communicate using HTTP very reliably, and you can access the information in the websites. So when we talk about the MQTT and CoAP protocols, we can actually see that the power consumption, when we consider the power consumption, we have MQTT. In MQTT, we have higher power consumption than CoAP. So as you are aware, actually MQTT protocol uses this MQTT broker in between the devices that are connected. So the broker is doing some additional work there, and therefore it needs to consume more energy for the MQTT applications than the CoAP applications, where you just directly, talk to the server and the server respond back with a certain response. So in here, MQTT is like broker is acting as an intermediate server, where it computes where the data should go and where the data should be published and so on. So it is doing some additional work here. So therefore, the energy consumption is higher in the MQTT than CoAP. However, once we take into consideration the transport protocol that is used by the MQTT, the MQTT is using the TCP protocol, which is more reliable than the UDP protocol that is used in CoAP. So therefore, MQTT data transfer is more reliable when compared to the CoAP communication. And then communication model that is used is different. So in MQTT, we use a publish and subscribe model, whereas in CoAP, we use a request and response model. Then in connection model, once we consider how the devices can be connected, the MQTT protocol can connect M to N devices. So if there are M messages on one side, it can connect up to N messages on the other side. However, CoAP at one time, it can either connect between one-to-one devices, or one-to-many devices, or many devices to one device. So likewise, there's some difference there. So the complexity that the MQTT can bring is higher than the CoAP. Then once we consider what is better for IoT, we cannot exactly say CoAP is better all the time or MQTT is better all the time. So MQTT is better for reliable message delivery with minimal code, right? It uses minimum code to send the information to the subscribers and get the information from the publishers. However, in CoAP, we don't have much reliable communication, but it is good for instant messaging, like quick transfer of information with low latency and under low energy scenarios. So depending on the application, we can decide which communication protocol needs to be used in the IoT network. So if we want reliability more than latency, we can choose MQTT. And if we need latency, I mean, if we are concentrating about fast delivery of information more than reliability, we can choose CoAP. Right. So once we consider the Google trends, it shows that MQTT is more popular than CoAP protocol. So MQTT has been established as a more popular protocol, and therefore it is more stable, and I mean more stable in the industry and as well. I mean, people recognize it as a more reliable protocol. Right, so we have then another protocol which we call as a WebSocket protocol, where the WebSocket protocol is used to create a two-way connection between a client and a server. So in here we have a full duplex communication. That means two-way communication between the client and the server. So which means that the the client and the server will first initiate a communication between these two devices, right? Once the communication is open, the communication will be bidirectional, and the data that the client is posting will be seen by the server, and the server will also uh, post messages with low latency into this communication channel. So it will be seen by the client as if the server is like talking to him or her very quickly. So therefore, it is useful for scenarios where we use chat, where we use online chatting or online gaming. And once we need very quick responses from the server, we can use WebSocket protocol. and it is used for single long-standing communication. That means we can continue to have a chat with the server for a certain time period, and only if one of the devices want to close the communication, only this communication link will be closed. Right. So this is basically used for online games, chat applications, and also it is used for real-time data transfer between server and client. So we can also see how it is used in certain websites, right? So we can go to this website and we can see how it is used, right? So WebSocket is used for applications where we use chats or something like that. So this is a type of a chat communication system, right? So we can inspect how this protocol is available in the um, in this situation. So we can go to WS option and we can see how it is working, right? So I will refresh and I will again start the communication so that we can see the communication happening. So once I go to WS, I can see that uh, I have made a request using WSS protocol. So I hope you can see. So this is a WebSocket uh, protocol based uh, request that I have made in this website. So I can say something, right? So it will be like two-way communication. So in here, we will be using the WSS protocol, right? So that is basically regarding WebSocket protocol. So so for today, I will like to end the class with that information, and by that I will be finishing the physical design of IoT section. So basically we have started the introduction to IoT, then we start a physical design of IoT, uh, and then next we will talk about the logical design of IoT in the next class. So if you have any questions, you can let me know. So if we don't have any questions, we can wind up the session. So you can let me know in the chat if you have any questions, or else I will stop the video.